Imagine this for a second. You've just been handed a secret key, a key to a secret chamber. What's inside? Well, it holds the very first moments of our entire universe. This isn't some science fiction movie, right? This is the unbelievable, stunning reality delivered to us by the James Webb Space Telescope. We just call it the JWST for short. Look, for centuries, humanity has just been staring up at the night sky, and honestly, all we've seen is this beautiful, two-dimensional ceiling. But the moment we look out there, we're actually looking back in time. Just think about it. Light does not travel infinitely fast. It actually moves at a constant, finite speed. So, how does that really work? When you look at the moon, you're not seeing it right now. You're seeing it as it was about 1.3 seconds ago. When you look at the sun, you're looking at it as it was 8 minutes ago. And when you look at the nearest star, you're seeing it as it was over 4 years ago. The light from those unimaginably distant galaxies has traveled for billions of years just to reach your eyes. Now here's where the Webb telescope performs its most incredible magic trick. To be honest, the universe is expanding. It's stretching out. And as the universe stretches, those light waves traveling through it, they get stretched too. This is what scientists call cosmological redshift. The light emitted by the very first stars and galaxies started out, believe it or not, as visible light. But over the 13.5 billion years of that journey, that light wave has been stretched and stretched. It moved all the way from the visible spectrum right down into the infrared. And what is infrared? It's a wavelength totally invisible to the human eye. So this is the central challenge. To actually see the beginning of time, we must be able to see in the dark. We must see in the infrared. That is precisely what the James Webb Space Telescope was designed to do. It's not here to replace the Hubble telescope. It's its spectacular successor. It's equipped with a huge 6.5-meter primary mirror. It's coated in gold, and it's the largest ever sent into space. But here's the crucial part. It has to operate in the frigid cold of space. Why? Because every warm object, even the telescope itself, emits its own infrared light. To see that faint, ancient infrared light, the telescope must be kept at a bone-chilling temperature. We're talking about near 40 Kelvin. That's about minus 233 degrees Celsius. It has to be that cold. So what has this cosmic time traveler actually shown us? It has delivered us pictures from what they call the cosmic dawn. This was the era when the first stars and galaxies finally ignited. It happened just a few 100 million years after the Big Bang. SMACS 0723, the very first image released, was a deep field view. And look, it wasn't just pretty, it was a revelation. It showed us thousands of galaxies. Some of them formed a mere 400 million years after the Big Bang. They look smaller, they're clumpy, and they are much more chaotic than the mature spirals we see today. We are literally watching the building blocks of the universe come together. The pillars of creation, reloaded. Hubble took a famous picture of this star-forming region, but a lot of it was obscured by dust. Webb, seeing through the dust in infrared, pulled back the curtain on a cosmic nursery. It revealed thousands of newly formed stars, allowing scientists to measure how quickly they're actually forming. Exoplanet atmospheres. Webb has also turned its gaze closer to home, analyzing the atmospheres of those planets orbiting other stars. For the first time, we've definitively detected complex molecules, things like water vapor and even methane and carbon dioxide in the atmospheres of these distant worlds. This is such a critical step in searching for biosignatures, the chemical signs of life beyond our Earth. To be honest, the data from Webb is actually challenging decades-old scientific models. Astronomers had predicted that the first galaxies would be small and faint, but Webb has found surprisingly massive and chemically mature galaxies much, much earlier than expected. So, what's the real take-home message here? It's one of humbling perspective. We look at these incredible images, the stunning Carina Nebula, the breathtaking Stephan's Quintet, and we are reminded of one simple thing. Our sun, our Earth, and everything we know and are is built from the remnants of those first stars that exploded billions of years ago. The James Webb Space Telescope isn't just taking pictures, it's completing our origin story. It is showing us that we are intimately connected to the very beginning of time itself. Thank you for watching.